Hello everyone. Today we are going to learn a solar power based water supply schemes. Okay, we are going to learn how to design a solar power based water supply schemes. Okay, my name is Edson Bundala and my contact number it is here. Okay, so if you have any questions regarding the solar power based water supply scheme, don't hesitate to contact me. I will give you an assistance. Okay, why is the use of solar energy or solar power is recommended for water supply schemes? Okay, we say that a solar power, it offers a viable solution for providing a water supply in both rural and urban areas. Okay. Also, a solar powered water supply pumping schemes can deliver a sustainable and a cost effective method for accessing a clean water in these regions of urban and rural areas. So my friend, welcome for this interesting topic of how to design the solar power based water supply scheme. Okay, there is 5 steps in carrying out this exercise of designing the solar power based water supply scheme. First of all, let us understand that a solar power is utilized through a solar photovoltaic SPV systems which convert a sunlight into electricity for use in pumping water. Okay, so we use this PV or PV array, okay, which it converts the sunlight into electricity, and that electricity it is used in for pumping water. Okay, so my friend, there is 5 steps. Okay, the first step is to calculate the daily project water demand. As we know that when you are planning to design the water supply scheme, okay, first of all you should understand the project area, okay, where you are planning to install or to implement, okay, the water supply network, okay, which will serve that community. Okay, so the first thing, you should understand the water demand of the area. Okay, here I mean that you should consider all the available types of demand. Okay, first one, it is a domestic demand. Here you should understand, you should have the community population. How many people are you going to serve, okay, through your project? That is first step. The second one, it is institutional demand. Here, if on your community, okay, there is a school, okay, if also there is a dispensary, it is institutional. So you should consider the demand of that institution. Okay, and the third one, there is a new term, let me read to you. It is called float population. Okay, what is that? Please go and find that. What is a float population? When you are designing, you are estimating the demand of the community, you should consider the float population. Okay, what is that? I give you a task, go and find it. What is the float population? Okay, then if you need my assistant to understand more what is the float population, don't hesitate to contact me through this one number here. Okay, this one here. Through WhatsApp you may reach out to me, so I will help you to understand more what is the float population. Okay, thank you for your understanding. Okay, then the second step here, it is to determine the yield of the water source available and its quality. Okay, here I mean that you should understand your water source capacity, okay, by conducting the pumping test and also carry out the water quality test, okay, to see or to check the water quality, does it comply with the standards. Okay, so this second step you should carry out to understand its capacity of your source and also its quality. Okay, also in determining your source capacity, okay, you have to determine the maximum bore yield and also the maximum percentage of obstruction, how much percent the available water on your borehole will be utilized, okay, or will be obstructed, and also it will give you the estimate of the allowable yield of your borehole. Okay, that is the step number 2. And the step number 3 or third step is to determine the design flow and the total dynamic head for a pump design. Okay, here I mean that, okay, you should consider your project daily demand. What is the daily demand of the project area? Okay, and also in determining the TDH, okay, you should consider the static head, friction and the minor losses, and also treatment equipment losses. By summing up all of this, it will give you the total dynamic head. Okay, so if you need more explanation regarding step number 3 or step number 2, step number 1, don't hesitate to contact me. I will guide you how to determine these things here. Okay, and then the step number 4, okay, step number 4 is pump selection and the motor. Okay, let me introduce here. Okay, when we say a solar pump, okay, a solar pump is an application of photovoltaic technology which converts solar energy into electricity to run the pumping system. Okay, I hope you got me here. Okay, so solar pumps, okay, when we say solar pumps, these are inexpensive, long lasting, simple to install, and require a little maintenance. Okay, this is the advantage of using solar pump. Okay, so when you are going to select your pump, okay, you should consider the step number 3, design flow and the TDH. Okay, and then in this step number 4, we are utilizing the manufacturer's software tools for pump sizing. Okay, there are various manufacturer software tools which are used for pump sizing. Okay, there is a Grundfos, there is a Semper, National Water, okay, pump, and many more. Okay, so if you need an assistance of sizing, okay, pump sizing by using the manufacturer tools, don't hesitate to contact me. I will guide you how to use the manufacturer software tools for pump sizing. Okay, mostly we are using the Grundfos, Simpa, Wiro, and National Pump. Okay, through this step number 4 of pump selection by using the manufacturer software tools, okay, it provides us a pump curve. Through that software we are getting the pump curve, okay, which help you, okay, which will help you to identify the most suitable pump. Okay, because as you know, we have to insert or to enter the design queue, the TDH, then we allow the software to compute, okay, to give us the best choice of the pump. Okay, then through the pump curve we can now select or identify the most suitable pump for our project. Okay, that is the step number 4. And the last step, okay, it is the design the PV system. Okay, here the aim or purpose of sizing the PV system, okay, is to ensure, okay, is to ensure it produces our PV, it produces a sufficient water to meet the daily demand throughout the entire year. Okay, as we know here, in PV, design the PV system, we are using the tools, software tools. Okay, here software tools are used in designing the PV system, where we should enter our project location on that software or that tools. Okay, we enter our project location, then through that tools it enables us, or it helps us to get the solar irradiance and also ambient temperature. Okay, by getting these two parameters, it simplifies our work of designing the PV system and then coming up with the PV system which will meet our design. Okay, so my friend, on your left hand side corner here there is a schematic diagram, okay, of solar power based supply scheme. Here we have this borehole here where we installed our pump and the motor, and then on the left hand side we have the PV array. Above there is a sun. Okay, the PV array, it converts the sunlight into electricity. Then we have the water tank, then we have distribution system, and at the end we have the water tap where our users or our customer will tap that water, okay, or will fetch that water through our water tap. Okay, so on left here down there is a PV array with a water supply. As you see, adequate water is supplied through our solar powered water supply system. So my friend, this is my certification. Okay, I got this certificate through the Global Water Center. I attended the 5-week course of solar powered based supply schemes. Okay, so I participated that course and I achieved to get this certification. So my friend, if you have any questions, you have a project, you want to design a solar powered based supply scheme, don't hesitate to contact me. I will assist you on designing your system. Okay, so my friend, thank you for your attention. Okay, this is my contact number, so you might reach me through this number. Thank you and have a good day. Thank you.